Alright, here we go. Welcome back to the differential equations video. Let's read this problem. Solve this x plus y dx plus x log x dy equals 0 by showing that it's not exact and then constructing an integrating factor for it. So this is not exact. So let's show that it's not exact. To show that it's not exact, you could go to the previous videos where we already explained all this stuff. You just take this already had the x taken out or derived out, so we can do x plus y dx plus y dy equals d fx y dx dy equals hopefully in x y dx. So it should be exact, but they're telling us it's not going to be exact, so let's see that. So you can take the derivative of this with respect to y. That's going to give you 1. You're going to take the derivative of this with respect to x. That's going to give you log x plus 1. So you should be able to figure those out without me doing every derivative. So does 1 equal log x plus 1? No. So there's a problem. We can't do anything with this equation. But we can find an integrating factor, which is going to be of the form e raised to the dmxy over the partial y minus dnxy over the partial x dx. Whatever your second term is, your last term, see the dx, that's how you know you're using dx, over n xy, right? And ends right here. So what is this gonna be? So this is gonna be 1, because we already did it. It's right here. It's 1. It's just dy with respect to this. This is your mxy. It's the function with the partial x derived from it. And then we further derive the y from it to get this term, which is 1. So it's 1, and that's this term right here. Now dn dx. So here's your dn dx, and that came out to lx log x plus 1. So you're going to minus log x plus 1. And then over the bottom, you're going to have the n term, which is here, x log x. So you could tell that when you get rid of this parentheses and multiply that 1 through, that negative through, you get 1 minus log x minus 1 over x log x. These go away. You now have log x's go away, so you have the integral negative 1 over x, which is e is raised to this integral dx. So what is that going to equal? This is your integrating factor now we're figuring out. This is going to equal negative log x, e raised to the negative log x, and that's going to be equal to, put the negative on top, you have e log x to the negative 1. These are inverse functions, they cancel out. This is e to the negative 1, which is to say it is 1 over x. That's your integrating factor, 1 over x. Alright. So let's look at the original formula here. X plus y d x plus x log x dy equals 0. This was not exact. We came up with the integrating factor, which is just this formula right here. Okay? And that gave us 1 over x. Now multiply through by 1 over x here and here. And what do you have? You have 1 plus y over x dx plus log x. The x's cancel each other out, you get 1. dy equals 0. Now we can show that it's exact. So the derivative of this with respect to y is going to be 0, and then this is going to be 1 over x. Just the coefficient of x, of y. Okay, here you're going to do dx. So what's dx? 1 over x. Are those things equal? Yes. Therefore, now you have an exact differential equation. You can solve it now. Now that you've done that to it, it's exact, and you can solve it. And you applied this, you multiplied this 1 over x to the whole thing, all the way to the other side. Now how do you solve it? Well, this is already the function. This right here, which is mxy, is equal to the partial of the function xy with respect to x. So if we integrate that dx, we're going to have some kind of form of the function. So let's integrate this. This is 1 plus y over x dx. That equals x times plus y log x. This is just log x with y. Plus g prime y. Go over the other videos if you're not quite understanding this. We already explained that, where that comes from, that g prime y. Alright. Oh no, it's not g prime y, it's regular gy. It's not, I'm sorry, it's not g prime, it's regular gy. Now, we take the derivative of that, x plus y log x plus gy over, and we are going to integrate it with respect to y, derivative with respect to y, so that we can compare it to this term, because this is going to be equal to the n term. So, that's going to be 0, that's going to be, with respect to y, it's going to be log x plus g prime y. So this is n, so we set that equal to let's set that equal to log x plus 0 so these go away, g prime y is equal to 0. Do you see that? Let's integrate g prime y dy, or let's integrate, in other words, let's integrate 0, dy prime equals 0, equals a constant. So, what is the final solution? Final solution is x plus y log x equals c. Right here. I just plugged it back into that. Because here c, that's my integrated g prime to give it my gy. And this is the answer. Thank you.